All right, integration by parts. If u and v are functions of x, then the integral given in this form, that is integration of u dv, is equal to u times v minus the integration of v du. So the formula here is the integration by parts formula, and we use this formula to evaluate the integral involving product of two or more functions. Now we have to be very careful in selecting u and dv. So there is a technique that you can use in order to select u and dv. So to select u and dv, we use the acronym L, I, T, E, T in order, where the function occurring first is u and the second is dv. Now, what are these LIPET? These are the name of different types of function. So your L is the logarithmic function. L is the logarithmic function. I is the inverse trig function. I is the inverse trig function. T is the polynomial function. E is the exponential function. And T is the trig function. So always when the integral is given in the form of product, we use integration by parts formula, which says integration of u dv equal to uv minus integration of v du. And in selecting u and dv, we use this acronym LIPET. And whatever comes first, that's your u, and the second one is dv. Example, evaluate the indefinite integral integration of 2x plus 1 times e raised to 3x with respect to x. So when you look at this integral, this is the integral of the product of the polynomial function 2x plus 1 and the exponential function 3x. So because the integral is given in the form of product, we are going to use integration by parts. That is integration of u dv equal to uv minus integration of v du. Now from this integral, we have to select what is u and what is dv. So in order to do that, we use the acronym LIPET. So here in this integral, we have the polynomial function p, and we have the exponential function e to the 3x. So that's your e. Since p comes first, your u will be the polynomial function. So we consider u equal to 2x plus 1. So let's write that down. Let u equal to 2x plus 1. And whatever is remaining now, that's your dv. So the remaining part is e to the 3x dx. So dv is equal to e to the 3x dx. In order to use integration by parts, you can see we need u, v. We have a u, we don't have v. So in order to get the v, we have to integrate this one. And here we have v du. In order to get du, we need to differentiate this. So what we do is we differentiate u and we integrate dv. So if we differentiate this, we get du equal to 2 dx. And if we integrate the second, we get v equal to e to the 3x over 3. Now we can use our integration by parts formula. Now the integral, which is 2x plus 1 e to the 3x dx, will be equal to uv minus integration of v du, where v and du are the functions which are here. So let's make that substitution. That's equal to u times v. So we are going to multiply these two, u and v. U is 2x plus 1 and v is e to the 3x over 3. So if we multiply, it will be 1/3 2x plus 1 times e to the 3x. Then minus, we have integration, minus integration of v du. V is e to the 3x over 3 and du is 2 dx. So if we multiply, it will be 2/3 e to the 3x dx. So it will be 2/3 e to the 3x dx. Now in next step, we write the first one as it is, 2x plus 1 e to the 3x, then minus. In this integral, 2/3 is a constant multiple, so we can take that out. So let's write 2/3 multiplied to integration of e to the 3x is e to the 3x over 3, e to the 3x over 3. Since we are done with the integral, now we need the constant of integration. So we write plus c as the constant of integration. Now all we need to do is simplify this one. 1/3 times 2x plus 1 multiplied to e to the 3x, then minus 2/3 times, this is 3 in the denominator, which is 1/3. So 2/3 times 1/3 is 2/9, 2/9 e to the 3x plus c. Now we can simplify one more step to write our final answer. So what we can do is, because we have e to the 3x here in the first term and also in the second term, we are going to factor that out. So that will be equal to, if we factor e to the 3x out, let's see what we get. In the first term, we have 1/3 of 2x plus 1. So technically, you can multiply this 1/3. So 1/3 multiplied to 2x will be 2/3 x. 1/3 multiplied to 1, that is 1/3. Then we have a minus. And from the second term, e to the 3x is already factored out. Here we are left with negative 2/9. So minus 2/9 plus c, which is equal to 2/3 x. And here we have 1/3 minus 2/9. 1/3 minus 2/9 is 1/9. So plus 1/9 multiplied to e to the 3x plus c. So that is the value of the integral given here. Example, evaluate the indefinite integral integration of x squared minus 1 times e to the x dx. So if we look at this closely, you can see that this is the product of the polynomial function and exponential function. So because we are integrating the product of two functions, we can use integration by parts. Sometimes if one of the functions is the polynomial function like this, and when you derive this continuously, if it goes to 0, instead of using integration by parts, you can also use a quick method called the table method to evaluate this integral. So I'm going to show you how you can use table method to evaluate this integral. So what we do is we select the integral which will ultimately go to 0 by continuously finding its derivative as u, or the first function. So your first function is x squared minus 1. Because if you find the derivative of this one continuously, it will go to 0. That is, in next step, x squared minus 1, if you find the derivative, it will be 2x. If you find the derivative again, it will be 2. If you find the derivative again, it will be 0. And the second function we have here is the exponential function, e to the x. In the first function, we find the derivative continuously. Now for the second function, we have to find the integral continuously. So the integration of e to the x is e to the x. Again, integration of e to the x is e to the x. Again, integration of e to the x is e to the x. So once we do this, it is just the matter of writing the answer. So now, this is how we can write our answer. Now the integration of x squared minus 1 e to the x dx will be equal to, what we do is we multiply like this. We multiply like this. So x squared minus 1 multiplied with e to the x, 2x multiplied with e to the x, 2 multiplied with e to the x, and because there is 0 after that, everything will be 0. So we just need these three. We consider the first one as a positive, second as negative, third as positive. If we have more, we'll continue changing the sign. So the first one will be e to the x multiplied to that with a positive sign. So that is x squared minus 1 e to the x. The second one will be, if we multiply this one, it will be 2x e to the x, but with the negative sign. So minus 2x e to the x. Third one will be positive, so we put a plus sign, then 2 times e to the x. Because this is the indefinite integral, we add c at the end, that is the constant of integration. Now let's simplify this one. In these three terms, first, second, and third, e to the x is a common factor, so we can factor that out, e to the x out. From the first, we have x squared minus 1. In the second, we have minus 2x. And in the third, we have plus 2. This is equal to, let's simplify, x squared minus 2x. Then here we have 2 minus 1, which is plus 1, e to the x. And we have that constant of integration c. So this is the value of the indefinite integral given here. So I use the table method to evaluate the integral. You can also use the integration by parts by selecting u as x squared minus 1 and dv as e to the x dx. Example, evaluate the indefinite integral, integration of e to the x, e to the 2x times sine 2x dx. So this is the product of two functions, e to the 2x exponential function, sine 2x, that is the trig function. So because this is the product of two functions, we are going to use integration by parts to evaluate this integral. Integration by parts says integration of u dv equal to uv minus integration of v du. Now we need to select what is u and what is dv. In order to choose u and dv, we use the acronym LITET. Here we have the exponential function and trigonometric function. And because e comes first, your u is the exponential function. So let u equal to e to the 2x. Let u equal to e to the 2x and dv equal to everything other than e to the 2x, that is sine 2x dx. Sine 2x dx. This implies first we differentiate u, so it will be du equal to 2 e to the 2x dx. And the second one we integrate, it will be v equal to integration of sine 2x is negative cosine 2x over 2. Now I'm going to use integration by parts formula. I'm going to call this integral as I. So I can write this as I is equal to uv minus integration of v du. So I is equal to u times v. So we are going to multiply u and v. So we'll get negative e to the 2x cosine 2x over 2. So negative e to the 2x cosine 2x over 2. So that's your u times v, then minus integration of v du. So we are going to multiply these two. If we multiply these two, the result will be negative. Here is also negative, so it will be positive. Then if I multiply these two, 2 in the denominator and 2 in the numerator cancels. I'll have e to the 2x cosine 2x dx. So integration of e to the 2x cosine 2x dx. Again, when we look at the second integral, it is just like the question, not exactly, but here we have sine 2x, here we have cosine 2x. So very similar, we have the combination of exponential function and trigonometric function. So we have to use integration by parts again. So for this one, to evaluate the second integral, I'm going to consider u as e to the 2x and dv as cosine 2x dx. So let's make that. Let u equal to e to the 2x and dv equal to e to the 2x. Hold on. E to the 2x is already taken. So dv equal to cosine 2x dx. So this implies we need to differentiate the first one. So du equal to 2e to the 2x. And we are integrating the second. Integration of cosine 2x will be sine 2x over 2. Sine 2x over 2. So now we are going to use integration by parts formula for the second one, for the second integral. So we can write like this. Hence, I'm copying this step. I equal to, I have negative e to the 2x cosine 2x over 2, negative e to the 2x cosine 2x over 2, then plus, for this integral, because I'm using integration by parts formula, I'm going to write that as uv minus integration of v du. uv minus integration of v du, where uv and du are here. So we are going to make that substitution in next step. So let's make that substitution. On the left hand side, I have I is this integral. I is equal to, here I have negative e to the 2x cosine 2x over 2, then plus u times v, plus u times v. If we multiply u and v over here, okay, if we multiply u and v over here, we get e to the 2x sine 2x over 2. E to the 2x sine 2x over 2. That is u times v, now minus integration of v du. So v is sine 2x over 2 and du is 2 e to the 2x. So if we multiply, 2 and 2 get cancelled. We get integration of e to the 2x sine 2x dx. So it will be e to the 2x sine 2x dx. So after working this long, we get the same problem which was there. Integration of e to the 2x sine 2x dx. Now, what we are going to do is, we are going to substitute this by I again. So we can write like this, I equal to e to the negative 2x, hold on, negative e to the 2x, negative e to the 2x, cosine 2x over 2, plus e to the 2x, sine 2x over 2, minus I, because this is same as the original integral I. Now we can bring this I on the left hand side, or you can add I on both sides. So this becomes 2I equal to, here we can see we have e to the 2x over 2, e to the 2x over 2, that's a common factor. I'm going to factor that out. E to the 2x over 2 can be written as half e to the 2x. And then here we are left with sine 2x. Here we are left with minus cosine 2x. So this can be written as sine 2x minus cosine 2x. I'm not looking for 2i, I'm looking for the value of this integral I. So I'm going to divide on both sides by 2. So if we divide, we get I equal to 1/4 e to the 2x sine 2x minus cosine 2x. One more step. We know I is this integral. I can be written as integration of e to the 2x sine 2x dx is equal to, so the value of this integral is equal to 1/4 e to the 2x sine 2x minus cosine 2x. And because this is the indefinite integral, we need the constant of integration at the end plus c. So that is the value of the indefinite integral given in this problem. Example, evaluate the definite integral 0 through square root of 2 over 2, square root of 2 over 2, x tangent inverse x squared dx. Now, looking at this integral, this is the product of two functions. Because this is the product of two functions, we are going to use integration by parts to evaluate this integral. Integration by parts says integration of u dv equal to uv minus integration of v du. Now, we need to select u and dv. We need to select u and dv from this integral. In order to select u and dv from this integral, we use the acronym LITET. In this function, we have the polynomial function x, and we have the inverse trig function I. Because I comes first, our u will be inverse trig function. So u will be equal to tangent inverse x squared. So let u equal to tangent inverse x squared and dv equal to everything else, that is x dx. X dx. We differentiate the first, du equal to derivative of tangent inverse x squared is 2x over 1 plus x to the 4. And we integrate the second, so v equal to integration of x is x squared over 2. Now we can use the integration by parts formula. Our definite integral 0 up to square root of 2 over 2 of x tangent inverse x squared dx can be written as uv minus integration of v du with the proper limit of integrations from here. That is equal to u times v. So we are going to multiply u and v. So if we multiply these two, it will be x squared tangent inverse x squared over 2. It will be x squared tangent inverse x squared over 2. Or we can simply write this as x squared over 2 tangent inverse x squared minus the integration of v du. V is this one and du is this one here. So if we multiply, 2 and 2 get cancelled. And if we multiply x squared times x, that will be x cubed over 1 plus x to the 4 dx. It will be x cubed over 1 plus x to the 4 dx. Now we need the proper limit of integrations. The limit of integration is from 0 up to square root of 2 over 2. So for the first, 0 up to square root of 2 over 2. Second, 0 up to square root of 2 over 2. The first integral is already evaluated. So all we need to do is we need to simplify this one using the fundamental theorem of calculus. That is, you plug in the upper limit, simplify this one, subtract and plug in lower limit and then simplify. So for that, if we plug in upper limit, if we plug in square root of 2 over 2, square root of 2 over 2 squared is half. Half divided by 2 is 1/4. 1/4. Then we have tangent inverse x squared. If I plug in square root of 2 over 2 and square it, that is half. Now we subtract and plug in lower limit. By plugging in lower limit, 0 squared over 2 is 0. 0 times tangent inverse 0, that's also 0. So I'm technically subtracting 0, so I don't need to write anything for that. Then minus, in order to evaluate this integral, we can see that the derivative of 1 plus x to the 4, the derivative of quantity which is there in the denominator, derivative of 1 plus x to the 4 will be 4x cubed, but we just have x cubed in the numerator. But we can adjust that. If I multiply there by 4 to make 4x cubed and then divide it, we'll be able to use one of the techniques of integral that we have learned in Calculus 1. So when we multiply and divide by 4 like this 1/4 is a constant multiple. It's outside the integral. We can write like that. Now the derivative of denominator is in the numerator. So the value of the integral will be natural log of absolute value of the denominator, 1 plus x to the 4. I don't need the absolute value here because x to the 4 will always be positive. And when you add 1 to that, it will always be positive. So I don't need the absolute value. And we need to evaluate this between 0 and square root of 2 over 2. 0 and square root of 2 over 2. Let's simplify this. This is equal to, our first term here is 1/4 tangent inverse half, and then minus. Now we need to evaluate this one using the fundamental theorem of calculus. So we plug in upper limit, we simplify that, we subtract, plug in lower limit, and simplify that. If we plug in upper limit, let's see what we get. There is a minus, then 1/4 of the natural log of square root of 2 over 2 raised to 4th power. Square root of 2 over 2 raised to 4th power is 1/4. 1/4 plus 1 is 5/4. 5/4. We subtract and plug in 0. If you plug in 0, 0 to the 4 is 0. 0 plus 1 is 1. It becomes natural log of 1, which is 0. 0 times 1/4 is 0. So I don't need to subtract that 0. So this is what I get. Now we can simplify this a little bit. You can see that there is a common denominator of 4, which we can write in the denominator like this. In the numerator, we have tangent inverse half, or 0.5, minus natural log of 5 over 4, or 1.25. Now, we can simplify this using calculator to get the approximate value of 0.0601. So that is the value of the integral, the definite integral, which is given here. So in order to evaluate this definite integral, we use integration by parts.